Okay, so we're going to look at some examples about evaluating and looking at the graphs of the inverse functions. Um, Before we start, I want to show you this chart over here, and you can look at it on your sheet. This lists the domain and range of your inverse functions. It's a little different. Okay, remember you're inputting a value for the function, and you're getting at an angle. So you might think it's strange that you have a limited range, like a squeezed range, but I think it'll become clear in a minute as to why that is. And mainly it's because of this word right here. That it's got to be a function. And we'll talk about that in our second example. But right here, right off the bat, we are going to look at part A, which asks us the arcsine of negative a half. So where is the sine negative a half in its domain? Well, here, this domain goes from negative pi over 2 to pi over 2. That's just what it does. So we're looking at this side of the circle only. Where does the arcsine, or where does the sine equal negative a half? If you're good enough with your unit circle, you should know that it's going to be down here. So we're looking in the second or the fourth quadrant, and it's the first one down. So it's 11 pi over 6. Well, we can't answer 11 pi over 6 because that is technically not in our range, right? We have to answer between negative pi over 2 and pi over 2. So we need to know what the coterminal is to 11 pi over 6. So these idea of coterminals are pretty important for us, guys. So the coterminal angle that fits in here is going to be a negative number. And you can think of it this way. It's pi over 6 back from 2 pi, right? That's what 11 pi over 6 is. So what if we did pi over 6 back from 0? Because 0 is the same thing as 2 pi. Well, this would be negative pi over 6. So this is what our answer would be for the arcsine of negative a half. We then move on to the inverse sine of the arcsine of the square root of 3 over 2. So where in my domain is the sine square root of 3 over 2? Well, it's up here, right? We know it's positive. It's the largest value before we get up to 1. And that is at pi over 3 or 60 degrees. So that's just pi over 3. Our last example is when is the sine, or excuse me, where is the sine 2? Is what it's basically asking. What is the arcsine of 2? Where is the sine have a value of 2? Well, interesting thing here is that I'm going from negative 1 to 1. I'm not getting any bigger, any smaller than those numbers, right? So where would the sine be 2? Well, nowhere. There is no place that happens. It's not possible. The sine of an angle can never, ever be bigger than 1 under any circumstances. So this is not something that we can evaluate. Now, a major thing about these graphs is that we are going to look at different places on the unit circle where the sine has a particular value. And remember, we're inputting those values in to get an angle back out. So that's this is very important for us, okay? So to understand, and this explains why our range is limited. Again, it has to do with this idea of being a function. So first we look at, okay, so normally we go to an x and plot our x, and then, or we find our x, we find our y value, and then we go forward. So negative 1, where is the sine negative 1? All right, well, negative 1, looks like we're down here, okay? So this is 3 pi over 2, okay? So 3 pi over 2 is like right up here. But it also is true for any coterminals to that. Well, what's the coterminal to 3 pi over 2 in the negative range? What is that? Well, if we think about it going backwards, or if we subtract 2 pi from 3 pi over 2, you will find that this is going to be at negative pi over 2. So right here. And that makes sense. This is 2 pi apart. You can kind of see that in the graph. The fact that these 2 points are on top of each other should tell you that this function will not pass the vertical line test, which means it won't actually be a function. The only way for it to be a function is for us to limit our range. But we're gonna continue and plot some different points here. So next one we have is a half. So where is the sine a half? Okay, so first place is at pi over 6. And since we're talking about a y value, it's going to happen on the other side as well. So this is going to be at pi over 6 and also at 5 pi over 6. Or excuse me, I'm looking at negative a half. I apologize. Negative a half. Sorry, guys. So we're looking at 7 pi over 6 and 11 pi over 6. So 7 pi over 6 is going to be a little bit above pi. And 11 pi over 6, that's going to be a little bit under 2. But what about our coterminals for sine? Well, if we take 2 away from 11 pi over 6, we get negative pi over 6. And we also have, so if we have 7 pi over 6, we take 2 away from that. That's going to be negative 5 pi over 6. So we're looking like this. So now we go to, when is the sine 0? Well, our sine is going to be 0 at pi and at 2 pi. Right? It's also going to be at 0, at negative pi, and at negative 2 pi. Well, you can see, you can go around the circle and find this out, but as we kind of continue making our points, we're going to have this sort of symmetry that pops up. So if we draw a curve through these sets of points, you'll see that it is symmetric, and it looks just like a sine graph, sort of, from the side. If you tilt it sideways. Well, when we do our vertical line test, right, all these places, right, we can't have this happen, right? We can't go about this because this function won't work, right? I can't plug in one number and get a bunch of different outputs. That's not a function, right? I only need one output per input that I give it. Just one per input. I can't get any more than that. So in order to achieve this status of being a function and being useful to us, we have to limit the values that we have. So what we're going to do here is they cut it off at these two places, which this is pi over 2 and this is negative pi over 2. Because within here, every possible value of sine exists, right? We go all the way from negative 1 to 1. So we can input any sine value, and we're going to output any angle. Now, sometimes we may just have to adjust the answer that we get to the unit circle because, again, we're going to get some negative angles and whatnot. But this area here will work just fine for us when we solve for stuff. But this is how it graphs. This is why it has an unlimited range. Again, we're looking at this function here. So where you're allowed to answer and what you're allowed to input. Again, you have to input a real value of sine or cosine in. Now remember, tangent, if we were to use arctan, tangent can be anything. So you can plug in any number you want, but you're only going to get a number between negative pi over 2 and pi over 2. So let's look at finding these exact values. So for A, we've got arc cosine of the square root of 2 over 2. So for cosine, we answer in the top part of the circle. So where is the cosine, the square root of 2 over 2? Well, right here. We've got a positive square root of 2 over 2. And right here, that's pi over 4. That is in our domain, so we have pi over 4. B says, what about the inverse cosine, or the arc cosine of negative 1? Where in this giant range of the upper part of the circle are we at negative 1? Well, the cosine is going to be negative 1 here. So this answer is pi. Flat out, and you're done. So C asks us the arctangent of 0. Remember, we're answering between these points. We can't be negative pi over 2 or pi over 2, but we're answering in the middle. So where would the tangent be 0? What I tried to describe to you guys earlier is that the tangent represents a slope of a line. Okay, so you have these different lines that connect these dots across the board. So like 7 pi over 6 and pi over 6, they have the same tangent, and their tangent is the slope of this line. Well, when is the slope 0? That's going to be on this line here. That's the only slope that is 0 that connects these 2 points. And that will happen at 0. And then D, last, is when the arctangent of -1. So when is my slope -1 within my range? Well, let's draw a slope of -1. How do we get that? Well, -1 would be these guys here, right? Straight through the middle. Let me draw that a little bit better. Straight through the... Terrible. A little bit better. Okay, so straight through the middle. So both of these angles, 3 pi over 4 and 7 pi over 4, have a tangent of 0. Well, problem is that neither of those are in my domain, right? Because I'm answering from negative pi over 2 to pi over 2. So I've got to convert those. Well, negative pi over 2 to pi over 2 is on this side, so I can't even use 3 pi over 4 anymore. I've got to use this 7 pi over 4 now, but I've got to convert it. If I think about it, one of its coterminal angles, if I go backwards 2 pi, I'm going to end up with negative pi over 4. So that is a way of using and understanding these functions. You're looking for where does the cosine equal this, or where does the sine equal this? And the answer is always going to be some angle. But it's very, very important for us to find our angle within the ranges that they provide.